All right, let's talk about scientific discovery. We're going to dig into what really drives it forward. But we're not just looking at the usual suspects. We're on the hunt for a hidden ingredient, something that's powered some of the biggest breakthroughs in history. And we're going to start with a pretty simple question. So, if I ask you that, what's the first thing that pops into your head? For most of us, the answer feels, well, pretty obvious. It's all the stuff we learned back in science class. First up, you're probably thinking about hard data. The cold, objective numbers and observations. This is the raw material, the stuff that we see as totally indisputable. And then, of course, there's the process itself, rigorous, controlled experiments. This is the absolute bedrock of the scientific method, right? Meticulously designed to test everything in a methodical, repeatable way. And this is a big one. It all has to lead to testable theories. You've probably heard of this idea. It's called falsifiability. It basically means that for a theory to be truly scientific, there has to be a way to prove it wrong. It's what separates science from, well, pretty much everything else. But here's the twist. What if I told you that hiding behind all that data, behind all those experiments, there's another ingredient, a really powerful, absolutely essential part of science that, and this is the crazy part, can't be tested at all? And that's where things get really interesting. This brings us to a connection that's pretty surprising, one that kind of blurs the line we usually draw between hard science and what a lot of people think of as the softer world of philosophy. Just listen to this. This quote totally nails the core of what we're talking about today. It's this idea that discovery isn't just about what you can prove. It's also about what you have faith in, what you believe in before you have any proof at all. These are what we call metaphysical ideas. So what are we actually talking about here? Well, metaphysical ideas are these huge speculative concepts about how the universe fundamentally works. You can't prove them right or wrong with a simple experiment. But, as we're about to see, they give science the framework it needs to even get started. Okay, so you might be thinking, if you can't test them, what good are they? Well, it turns out they have a super important job to do. They act as a kind of hidden guide. Think of it like this. These ideas are like a guiding compass. Before a scientist has a detailed map of some new unexplored territory, they need something to give them a direction to head in, right? Metaphysics gives them that first push, pointing them toward areas that might actually be worth exploring. And this, right here, is the central paradox. Science literally defines itself by being testable, by being falsifiable, to keep itself separate from metaphysics. And yet, when you actually look at the history of science, it's totally clear that these untestable metaphysical ideas have been absolutely critical for pushing science forward. And hey, this isn't some new age thought experiment. This partnership between speculation and science has been the engine for discovery for thousands of years. So let's just take a quick trip back in time. I mean, you can see this pattern all throughout history. It starts way back with the ancient Greeks. Guys like Thales, who were the first to imagine that everything was made of tiny little atoms, a totally philosophical idea back then. Then you jump forward to Descartes and Newton, who were just speculating about the basic nature of matter and force. It kept going with Faraday and his revolutionary and at first untestable ideas about fields of force, all the way up to Einstein, whose work was so deeply guided by his own philosophical beliefs about reality. So you see this pattern, right? All these huge foundational concepts that science is built on today, like atomism, or the idea that light is made of particles, or that electricity acts like a fluid. Every single one of them started out as a purely metaphysical idea. They were just these untestable thoughts way up in the higher metaphysical regions, long before we had the technology to actually test them and bring them down into the world of science. So how in the world can an idea that you literally can't prove wrong be a useful tool for scientists? I mean, it seems like it breaks the #1 rule of science. Let's break this down with a really simple example. A scientific statement like, all swans are white, is totally falsifiable. All you gotta do is find one single black swan, and boom, theory's dead. But look at a metaphysical statement like, there are white ravens. That's not falsifiable. Just because you haven't found a white raven doesn't mean one doesn't exist somewhere. You could search the entire planet forever and never, ever prove that statement false. Now let's look at one of the biggest, most powerful metaphysical ideas in all of science, the principle of causality. This is the core belief that every single event has a cause, that everything can, in theory, be explained. You can't prove this is false, but it has been an unbelievably powerful guide for scientists. So how does this actually work? Well, a metaphysical belief, like every event has a rational explanation, it gets turned into a practical rule for scientists. Never, ever give up the search for universal laws. See? The rule isn't a statement about how the world is, it's a command for the researcher. And the result? It becomes this incredibly productive guide that just forces scientists to keep digging deeper, to never just accept, well, it just happens. So, what's the big takeaway here? It really points to a whole new way of looking at the relationship between these two ways of thinking. The real story is that they're not enemies locked in some big battle for the truth. They're actually partners. Metaphysics, with its big, bold ideas, provides the direction. It's the compass. And then science comes in with its super rigorous methods to actually survey the land and draw the detailed, testable map. At the end of the day, that's what these grand, untestable ideas really are. They're the unjustified anticipations, the bold guesses that get everything started. They're the imaginative leaps that fuel the whole scientific engine, creating the fertile soil where testable theories can finally start to grow. And that leaves us with a really cool question to think about. If history has taught us anything, it's that the great scientific breakthroughs of the future are being shaped right now by purely speculative, untestable ideas. So the question for us is, what are they? What bold metaphysical beliefs are guiding scientists today as they start to map out the world of tomorrow?